Good afternoon, Professor.
Yes.
Good afternoon, Professor.
Yes. Good afternoon. Good afternoon. I think that was the third. That was a
Good
half.
afternoon.
I love it. Oh my God. Just made my week. It's made my day. That and look at that. And the chat's going crazy. The chat is like off the expression, yo. Oh, this is great. I feel like if only this were actually like just for fun, it would be so much fun. Good afternoon. Thank you. I think that was and my view is off. So I think that was, hold on. Sorry. Good afternoon, Savannah. Good afternoon, Caitlin. Good afternoon, Caroline. Good afternoon, Amanda. And I think I know who said, well, okay, anyway. Good afternoon, Elda. Good afternoon, Sam AJ. Good afternoon, Elizabeth. I'm going to the chat now. Okay, seriously, my mood was so bad like a minute and a half ago, and you've just changed. Good afternoon, Amanda. Good afternoon, Caitlin. Good afternoon, Jamilet. Hi, Christina. Good afternoon, Elizabeth, with 2 exclamation points. Good afternoon, Chloe. Good afternoon, David K. Good afternoon, David P. Oh, they like conspired. Good afternoon, Felicia M. Good afternoon, Elda M. C. Good afternoon, Kimberly K. Good afternoon, Kevin. Good afternoon, Alicia. Good afternoon, Samuel. Hey, good afternoon, person who's in the waiting room and is going to run away if I don't. Hold on. The waiting room is so questionable. Good afternoon, Sophia. Good afternoon. Did I skip Amy? Sorry. Good afternoon, Amy. Good afternoon, Adon. And good afternoon, wait, Sam? Wait, I could have sworn we have 2 Sam. Oh, this is a danger now. I'm not taking attendance. I'm just noting. And good afternoon, Shamil. But oh, and Alicia's back? I thought Alicia was here. Okay. Good afternoon. Good. Oh, wait, didn't we have 2 Sams? Well, that's dangerous now. For each of those Sams now has more pressure on their attendance than they deserve. Good afternoon, Shamil. Awesome. But good afternoon, Sam. How? Definitely. Okay. All right. Good to see you all. Thank you again for your major indulgence last Monday. For what it's worth, and most of you, maybe not all of you, again, you are all ahead of me still in more ways than one. I'm behind you. There will not be any new real homework for a little while until we catch up to the homework you've been doing. I'm well aware that you still have to get things back and you have to know whether you're doing them right or not. Totally aware of that, and I totally apologize. The thing, so as I say, there's not any new homework tonight, and there might not even be Wednesday until I catch up to you. But it's very noted how much work you're doing and how the work, and I see that the work is starting to get a little harder. As far as last Monday, most of you, so thank you for indulging my little arrangement that I do sometimes, which I did last Monday. And I think any of you who even acknowledged like the communication about us being asynchronous, you got at least 3 points back already for doing that. I think all of you, if anybody's missing, let me know, but I think, so you got 3 points for acknowledging at any time. Thank you. And then many of you, then most of you actually, which I appreciate, watched at least a significant portion of the video that was posted for that class material. And then most of you wrote something to me that indicated that you did get something significant out of it, something that I wanted you to get out of it. So that's really great. So most of you got that back and got 9 points plus the 3 points. It makes 12 points. A couple of you might not have gotten it back yet, and it's not personal. And I'm aware, actually, no, let me say it definitively. A couple of you have not. It's random again who that is. You will get them back. But most of you should have gotten, most of you got 12 points back for that. Let me remind you again, and it's definitely not, and so thank you, and thank you for letting me do it piecemeal like that. Hopefully you see that. And it was up to a possible 16 points, because if you did show up on that Monday for the 10 minutes when I gave this Blitzkrieg announcement, then if you just remind me of that fact, you can get 4 more points for that. Some of you have done that, but some of you, just to remind you, if you've gotten 12 points on that thing, but you actually were there Monday, even for the 5 minutes when I was spazzily saying all this, just remind me, just resubmit it, or however we've said this works. Just remind me I was there. Like, you don't have to prove it or get government backing or something, but just if you were there and you, which means you went to the trouble of showing up, then you get another 4 points. And some of you have gotten that, but I just can't, don't leave it up to me to remember is all I'm saying. But so thank you very much for indulging that. Again, this is a long way of saying most of you, maybe not all, but most of you have now turned in more things than you've gotten back. Like, most of you have turned in a bunch of stuff and gotten some things back, whether small or big. And some of you have turned in revisions that you've not gotten back. Just a blanket statement that I'm aware of that. I might have a moment to thank you again in class personally. Or you can also always, it's also just a way of saying, if you haven't gotten something back yet, I do apologize. It's not personal to you. It doesn't mean you didn't turn it in or that it's late or anything. But if you're ever concerned, and some people have done this, a couple of you have emailed me or texted me just to say, like, did you get the blah, blah, or did you get that I put in this revision and I labeled it revision 2? You can do that. I mean, sometimes I'm faster with things like that than with actually grading a whole thing that takes time. So if you just want the satisfaction of knowing that you're good, that's no problem. Please do. There was one quick thing about that, but I can't remember, but okay. But yeah, just in general, I'm just saying, if you've turned in things, but you haven't gone back yet, it's probably not you, it's probably me. Okay. I think we're rolling on. Let me just look in the chat. Some things just happened in the chat. No problem. Thank you. Oh, no problem. Thank you. Direct chat. Thank you. Got it. Oh yeah. And last quick thing, and then we're going to start again. I want to do some material today, start catching up with some of these sheets. We're going to get to a point where we don't literally go over literally every single question of every sheet. We're going to get to that point, but right now I still would like to go over enough stuff so that you know what you're doing. And by homework 4, which many of you have turned in now, we're up to homework 4. I'm aware, you're aware, I haven't taught anything direct to help you to know how to do homework 4. I'm very aware of that, which is why we're going to, for you to think of on your own and try to put together and do your best. And then we're going to talk about it. That is the way it should be. Like, if you looked at homework 4 and you're like, wait, this is the first time I'm thinking about these ideas. That's right. It's the first time you're thinking about those ideas, and that's appropriate. Don't be angry at yourself or at me or think that you've missed it. But it's appropriate to a point. I obviously don't want to start asking you about, like, material way out here just yet without talking. So again, there's not going to be a homework 5 for a little while, but if you tried homework 4, the reason I'm saying all this, homework 4 was technically due. You still have time to try it, and nobody's gotten it back yet. We're soon going to get up to it. But if you sat down to try homework 4, hopefully a couple of you noticed there's an error in homework 4. One question is old and it refers to an equation on a website. I don't use the website anymore. We use this now. Maybe someday I'll use it again. But so if you saw that, hopefully you saw my posting in it, or I'll just ask, can you just do an electronic hand? Did you see the posting in the stream of Google Classroom? Yeah. Okay. Great. All right. Awesome. That means that worked. Great. Thank you. All right. So if you have any question about what I'm talking about, please direct chat me or private chat me, but cool. Thank you. So forgive. All right. Again, if you did do homework 4, yeah, actually, I'm just going to say this. Actually, yes, pardon me for this. And then we're going to move on. I always say that and I'm always lying, but hold on one second. Okay, just because, yeah, so technically homework 4 was due today. Nobody got it back. It was due like a minute ago. Just to acknowledge, I'm just going to say, like, if your name is Sam AJ or Sophia, or there's a good thing, like, thank you, Sam AJ, thank you, Sophia, thank you, Amy, thank you, Chloe, thank you, Alicia, thank you, Kimberly, thank you, David K, thank you, Amy, thank you, Caitlin, thank you, Amanda, thank you, Kevin, thank you, Jamalette, thank you, Felicia, thank you, Caroline, thank you, Adon, thank you, Savannah. Just a way of saying, I totally get it. Thank you. You're totally on top of things. You're very much not behind in this course. Potentially, you're like a little bit ahead in this course now. Like, you're very on top. if I didn't say your name, I'm not looking at your name. I'm not looking at a list of people who didn't do it or anything. I'm just saying, yay, thanks, cool, nod to the people that did do it. If you didn't do it yet, please try. Don't wait for me to explain things about it. Try it on your own and see what you could do. Then my explanations will be that much more fruitful. But okay, but thank you for those of you who are like totally leading the pack. Okay, now I want to go back to material and stop me anytime if you have questions about anything, obviously today, but I'm going to now go back. I'm going to change the screen. I'm going to now go back to finish up sheet number 2. I mean, homework sheet number 2, right? Sorry. I'm going to go back to sheet number 2. Oh, wait, I'm looking in the chat. I'm sorry. Oh, yeah, no problem. No problem. Thank you. Anybody who's sending me a direct chat about technical things, I totally get it. Thank you. No problem. Don't you hate when people say, I totally get it? They never totally get it. Okay. We're going to go back to sheet 2. I'm going to do a sort of quick. Oh, okay, cool. Okay. I'm going to go. Thank you. That counts as closing the loop, direct chat person. I'm going to go to the last problem of sheet 2. So hopefully you've noticed the pattern too. Like these equations that are up on the board right now, they're on the front sheet. They're like the goal of today. Usually when I put equations, again, it's not to say this is what it's not to say this is what we already understand. It's not usually like review from last time. It's usually like, this is the objective of today, what we're trying to get to. And sometimes we don't, but so it is always good to have them, to try to write them down even before you know anything, to see where I'm ultimately trying to get to with stuff. But anyway, that's what we're trying to get to. We're going to try to get to it. And they're particularly helpful for homework number 4. We're going to get to those equations by means of finishing up sheet number 2. Okay, hold on. Oh, that's totally not anything. Sorry. Nothing to see here. Okay. All right, so I'm going to go over the last, oh, someone's here, sorry. Okay, I'm going to go over the last problem, Grandma Grimm. Here's what I want to, and then we're going to move on, and I'm not going to, it's a fascinating problem in a way. You may have gotten it right, you may have gotten it wrong. I do want to hear your thoughts, but I don't want to hear them right at the moment. It's a fascinating problem unto its own rights, but it's extraordinarily similar. It's very similar to problem number 2, the hill figure problem. You go up the hill, you come down the hill. Very similar to that. Either one of them, if it had been the first problem you've been given of that type, like I expect most people in life, at any stage, most people, many people would get those wrong for very, very reasonable reasons. And then hopefully once they saw the right answer, it would show them something about physics. Now they're both either one we could have started with. Once you know one, it's a lot easier to understand how to do the other one. Okay. Now, what I got from your feedback, your submissions from Monday night, or from having watched the YouTube video and so forth, I actually do feel like most of you did understand my YouTube explanation of the up the hill, down the hill. If you guys are, it seemed pretty convincing what most of you told me, that you might have gotten it wrong before, but now you totally see what the right answer is. I mean, I feel like you did watch the video and that you do get it. And I'm trusting, and I appreciate that. Therefore, I'm not going to reinvent that whole wheel right now. I'm going to go straight to showing you how that information can be cross-applied to this problem. Last way of putting it, if you did one problem and then the other, like and handed them in like you're supposed to do. Of course, you could easily get them both wrong, or there's no way you could. It's very possible that you wouldn't benefit from the Hill problem while you're doing the Grandma Grimm problem because you're thinking the same thing on both. But now that you've thought of the Hill figure problem, I think what I'm really trying to say is you might want to let your wheel spin a little bit right now, even while I'm talking, and see, maybe especially if I'm getting boring or elaborate, you might want to, on a separate piece of paper right now, see if you can rework the Grandma Grimm problem based on your finding in the uphill downhill. In fact, I might even give you time explicitly to do that in a second, because it's really similar. So here's the setup again, so I'm going to do the step method, right? So step one is DFP. Here's the diagram, and you might have to run me, but I believe and please do in the chat, either confirm or deny. I believe the problem says it's 80 kilometers from yes, thank you, Caroline. It totally counts as participation. Thank you. Okay, so it's 80 kilometers from where Ray Riding Hood. Oh, and Caitlin, thank you. I love this. God, and David, thank you. And yes, thank you guys. I thank you for making me feel alive. Okay, so it's 80 kilometers, and you can submit. Okay, so it's 80 kilometers to there, and then and it is also 80 kilometers back. How are we going to say that? We say what the other given here is that she goes out, Little Red Riding Hood goes out at 40. Yeah, at 40. I honestly have not kilometers per day. I think it's, maybe you can confirm or deny that. I think she goes out at an average. Yes. Okay. Thank you. Awesome. Thank you. Yes. Okay. Cool. So she goes out. Thank you, Caroline. Thank you, Caitlin. So she goes out at an average speed, like an absolute value, a magnitude of the average velocity of 40 kilometers per day. She goes out to 80 kilometers. Then she comes back. That's what I should say. Sorry. She comes back okay. If I recall correctly, now here's all this is the whole setup of the problem. She goes out at 40 kilometers per day. She goes back at an unknown average speed. So she goes out at 40, she comes in at an unknown speed. But the one other given is we want the average speed for the total round trip to be 80 kilometers per day. And the question is, so this is the diagram. This is the fact, as far as I know. And one big fact is that it's 80 kilometers of distance. So that was all DFP, right? I guess to be, well, yeah, so that's all DFP. And the question is, okay. Right, that's the question. So we've done step one DFP, we've done step two WIQ. I'm really tempted to make a whole I'm really tempted to have a whole discussion about this with you guys, but I'm not going, but I mean, I'm sort of really interested to hear what you think or if you've rethought, but I'm not going to because we need to have a discussion about something else in 5 minutes. So I'm going to say, just like the last problem, I'm sort of stalling because I want you to think for a minute. Like, let me put it this way. It's very, very likely that a lot of people in the room put 120 kilometers per day as the answer, right? You're going out. Am I getting my numbers right? Yeah. You're going out at 40. You're coming back at an unknown. You want the whole average to be 80. The question is, what's the unknown? I understand if a lot of people put 120, because a lot of people could be thinking, well, the average of 40 and 120 is 80. That would be very understandable, but that would be wrong for the exact same reason that putting 50 was wrong for the uphill downhill problem, right? The key thing I don't want to show of hands or anything, and I don't want to embarrass anybody or anything like that, but I do want you to be honest with yourself. If you put that the answer is 120, don't think you're crazy. Don't think you're a bad student. Don't think you haven't been paying attention or anything like that. Like, in fact, it shows you've been paying attention to a lot of math for a long time. It shows that you know how to average two numbers. But if you did put 120, I do want you to realize now that actually that's not right. And it's not a trick. It's not to be unfair. And we're not changing the rules of the game on you. It's true that the average of two numbers, 40 and 120, is 80. But what we're trying to say here in physics is that average speed is not defined to be an average of just any old two numbers. Average speed is total distance over total time. And that's the definition of it. And we don't have any definition or equation that says to get average speed, you have to average numbers. Like, so first of all, so let me remind you, so 120 is not the answer. That's number one. It's not the answer for the same reason that 50 was not the answer in the other question. Number two, like, remember, average velocity equals displacement over time. Average speed equals distance over time. Definition. By definition, it doesn't equal anything else. So that's the only thing we can use to solve this, okay? Or it's something that better, whatever solution it gets better be right. Side note, if you're thinking at all, well, this is like really, like, if you're thinking I'm trying to trick you, I totally can understand that. And like, for the first 10 years I ever taught this, I probably was being obnoxious about it. I'm not trying to trick you. I'm trying to reveal something that is tricky about the language of physics. But I also want to say it's tricky because it requires some thought, but it's not arbitrary and it's not cruel and unusual and it's not unfair. Like, what I'm trying to say is this: average speed is called average speed for a reason. What I don't want you to do after these two problems, don't take away, all right, so average speed is just called average speed because it is, because that's the way physics is, because that's the way physicists are. And like, average speed is just average speed and it doesn't have anything to do with averages. I just have to accept that. And like, it's my bad for ever thinking it had to do with averages. And, you know, all right, whatever physics people want to do, like, they're going to use the word average, but it doesn't mean average. Like, no, actually, what I really want you to know is it's called average speed for a deep reason, for a real reason, which we're going to get more and more deep into as we go through the course. But what I really want you to know is that average means the one particular value that best represents a whole collection of varying values. That's what average actually means, right? And there are different ways of getting an average for different contexts. I mean, something you certainly know from other areas of life. There's such thing as a mean average. There's a median average. There's a mode average. There's different, and there's equations that sometimes work for computing averages, like add up all the numbers and divide by the number of numbers. Sure, that sometimes works to compute an average, but it's sometimes that it works and it's a double equal sign, not a triple equal sign. And what that is, add up all the numbers and divide by the number of numbers. That's a way of sometimes getting a value that is the average, the one number that represents a whole collection of varying values. To be super blunt about this, when we ultimately got the answer on the YouTube video, and again, if you didn't watch it yet, please still do watch it. But at the end of the day, when we got that, if you go up a hill at 40 and you come down a hill at 60, the same hill, your average speed for that entire round trip journey is 48, not 50. Your average speed is 48 because we're actually taking the concept of average so seriously. It's not because we're tossing out the concept of average. I mean, that's the thing I'm trying to say right now. The reason you get the reason you get 48 as the average speed for a hill at which you ascend at 40 and descend at 60, the reason you get 48 is because we realize as physicists that if you went up at 40 and down at 60, then you only spent 2/3 of the amount of time going down, and you spent, or 3/2 the amount of time going up that you did, right? So in other words, it's equivalent, and I said this at the end of the video, but please understand that going up a hill and at 40 and coming down the same hill at 60 is equivalent to getting a 40 on a test, a 40 on a test, and another 40 on a test, and then getting a 60 on a test and a 60 on a test. It's equivalent to getting 3 40s and 2 60s. So if you averaged those all out, you'd get 48. In other words, what I'm really trying to say right here is please understand why you have to take the definition of average speed seriously is it actually ends up getting you something that is much more accurately and truly an average than just adding 2 numbers and dividing by 2. The true reality is we're averaging over time, and to just pick 2 possible numbers that seem to represent speed doesn't actually fairly capture the whole. So average speed really does mean average speed, but the way to get it is to go to the definition. So if I do that now in this case, and I say, all right, and I say here too, look, I don't think the average is going to be, I don't think 120 is going to be the answer because she's going out really slowly. And if she comes back any faster, she's going to spend a lot less time coming back than she did going out. So we shouldn't give the 2 numbers equal weight in the average. So the only way to do this is like the other problem and think about distance and time. Okay, so I want to speed this up a little bit. So I think for a second. Okay, so I'm going to say, so by the way, right above me is that step 3 GDP, right? So now I'm doing step 4 PAW. I'm starting to plug into the problem now. In fact, just to be nice, hold on a second, let me just make this clear. So like this was step 1 DFP. This is step 2. Oops, sorry. Step 2, what is the question? Now on the next one. So this is step 3 GDP. So now I'm doing step 4. I'm starting to apply to the particularities of the problem. Step 4 PAW. So consider the out trip. I'm going to do that thing that we did in number line in sheet 1. If I'm going to read. Okay, I'm going to back up for a second, just to be clear, because I know we're still getting used to each other and all that. X naught, remember X naught means initial position wherever you start. We've always said that by definition, that's not always zero. It could be something other than zero, but sometimes it is zero. And here we just started at the beginning of our journey. We made our journey, we came back. We could call the first step of our journey whatever you want. I'm going to call it zero because it's the most convenient, easy. In other words, I have no reason not to. So I'm letting where she started be known as zero. So X naught is zero. So just to make things easier. Okay. So I'm going to figure out how much time it takes her to go out. Well, the time it takes her to go out. So time, this is from, I just rearranged the equation, right? Like I did in homework 1 number line. Time is displacement over velocity. And again, stop me if I'm starting to go. But so time equals displacement over velocity. The displacement is so that's all just true. Technically, you could call that a step 3 GDP. I mean, that's just true. But I'm going to say here, like here in this problem, T equals 80 kilometers over 40 kilometers per day, right? This is the trip out. So the kilometers cancel. And you get that the time out is 1 over days, i.e. 2 days, right? The units work, in other words, like displacement units over velocity units yield time units because the kilometers cancel out and the per day in the denominator. So, okay, so okay. So now this is not an answer yet. I'm almost there, but this is just information. I mean, what I'm going a little bit faster than that last time, a little bit. I'm saying the only way we can get an average velocity or an average speed is to get total displacement over total time. I know the total displacement for this whole thing. The total displacement is 80 kilometers out, 80 kilometers back in. Well, right? I mean, we are looking for the velocity on the way back. That's what we're looking for, velocity on the way back. I'm claiming I don't think it's going to be 120. I'm claiming I have to solve for it using displacement and time. I want the velocity on the way back. So what I want we want the velocity on the way back in. In other words, we want the displacement over the time on the way back in, right? If we could get the displacement over the time, we would have the velocity on the way back in. Well, we know the displacement already. The displacement is 80 kilometers. So what I'm getting at, what I'm saying in a slightly roundabout way is what we need, what we're really looking for what we're really looking for, if you think about it, is the time on the way back. That's what I'm trying to say here. Like the question is asking what's the average speed on the way back in? But average speed equals distance over. Good question. Wait, good question in direct chat. V stands for velocity. So the question in the direct chat is V a variable or does it stand for velocity? Very good question. It does stand for velocity. But what I'm saying is it actually is the variable that we're looking for in this question. We're looking for, I mean, technically we're looking. So, okay, cool. Thank you in the public chat. Awesome. In fact, and let me back up a second because this might help the person who's in the direct chat. I'm not sure. Like technically we're looking for the average speed on the way back. Like that is the thing that the question is actually asking. Average speed on the way back, the way in, okay? Now I'm being a little fast and loose about speeds and velocity. Like I have all these equations for velocity. And in the end of the day, once I have the velocity means speed and direction. Once I get a velocity at the end of the day, the magnitude of that velocity vector, the size of it is the answer I'm looking for, speed. So I'm using my equations just to get answers, and then those answers will apply to the question being asked. But so V is what I'm looking for. I'm looking for the magnitude of the velocity, the speed on the way in. But what, and maybe the direct chat person can tell me if I answered their question. I'm not sure. I'm totally psyched with Nicholas. Thank you for saying it makes sense to you. Maybe I'm not sure if I'm really answering the direct chat person's question well or not. They can tell me in direct chat, but when they do. But what I'm saying to everybody is, here's like sort of my trick for the problem, or what I'm trying to drum in over these two problems is average velocity is displacement over time. Average speed is distance over time. That's the way we have to deconstruct them. That's the way we have to construct them to build them up. We can't be going on just averaging pairs of numbers to get these things, because truthfully, pairs of numbers isn't fair. Like the numbers are not equally weighted in the situations that we're being given. So we've got to break down our thoughts into distances and times. I mean, all of physics comes down to space and time. So I'm saying right now, if the question is asking me for what's the average speed on the way in, really, it's asking me what's the distance per time on the way in. And really the distance we were told is 80 kilometers. So really what I'm looking for, if you think about it, what I really am trying to get at is how much time does it take to get back in, right? That's what's unknown, the time on the way back in. So here's my approach. What I'm thinking is, sorry. What I'm doing right now, what I'm saying, maybe I should have said it 2 minutes ago. Technically, what I'm talking about right now is still, in a way, is up a step 3 GDP, or it's a mini step 3 GDP. What I'm saying is, look, but I mean, it could all fall under step 4 PAW. What I'm saying logically is, if we're solving for the time on the way in, isn't it generally isn't it a definition or a truth, even before we start this problem, that total time, round trip time, equals time out plus time in? Like, that's just a definition. Total time is all the time out. Like, the total time for a round trip is all the time out plus all the time in. That's total time. Therefore, total time in, the thing that we're looking for, is total time minus time out. Now, that's just a definition, right? It's not a formula. It's not a new physics equation. It's just, it's a definition of total, right? And if I make that clear to myself, if I just write it down, maybe I could have written it up in step 3. It actually makes me realize, like, oh, okay, I can get the time in as long as I know the total time and I know the total time out. Just look at the difference. Like, so if the total trip is supposed to take 4 hours and I eat up 3 of those 4 hours on the way out, then I need the time in to be 1 hour. And I'll just say that my final answer is 80 kilometers per 1 hour. I mean, I just made up that number, but right, as long as all I'm really solving for here is the time on the way in. I think the time on the way in should be whatever is left over after you've subtracted the time out from the total time. But where did I get that idea from, or why am I thinking those things? Because I think we know. I think we know the total time, and I think we know the time out. Why do I think we know that? Well, the time out, I'll change the color. I know this color is bad. The total time out, we just figured out, was 2 hours, right? Because it was 80 kilometers over 40 kilometers per day. So it was 2 days, right? We just figured that out. And like all we did was use speed, it was average speed equals distance over time. Well, same thing for the total time. Let's see the next page for total time. And I can flip back if you need me to at any moment, but on the next page. The total time, well, the total distance for this whole round trip is 160 kilometers. And the average speed for the whole round trip was given in the problem. It's a condition of the problem. It says how fast you want to come back in so that your average speed for the whole round trip is 80, right? It says that. Right? So I don't know if it looks, again, some of you in the room think I've used a lot of words to say very little. And you may, oh, good, I'm glad. Okay. And I was about to say, some of you may have already, I may have already lost some of you. So someone in the direct chat, I'm very psyched. Thank you. Someone in the direct chat is saying, wait, where did I get the 160 from? Very fair question. And I'll tell you, the 160 is the out 80 plus the in 80. In other words, if we're looking for the total time, the time for the total round trip, the distance for the whole round trip is 80 out plus another 80 back in, because she's coming back the same way she went out. And we were told in the problem that it was 80 kilometers to grandma's house. So the 160 is 80 plus 80 again. But that's really important. It's really fair. Could the person who put that in the direct chat, could you just tell me, please, in direct chat, whether I did just answer your question or not? Like when you get a chance. Yeah, okay, cool. Phew. And that's points good. No, because I'm sure that helped some other people too. And please, everybody understand, again, in these early classes, I'm trying to really have, my goal in these classes is, yes, to teach some fundamentals of physics, but it's also to send you the message to really believe me, especially in a Zoom class, that like, even if you think I said something 5 minutes ago, you're allowed to like, do I really think there's no stupid questions in life? Yeah, there are stupid questions in life, but they're not generally the ones that we think are stupid. Okay. There are stupid questions, and there are rude questions, but these are not those. A question that even if I said it 2 minutes ago, it's not stupid. And I'm not saying I did, by the way. But to make sure we are clear together, especially at this time of the semester, please do so. Even if someone else, like I think I just answered for one person where I got the 160. I don't care if there's someone else in the room who's just now woken up to the fact, awakened to the fact that 160 is important. and like, you need to know where I got it from. Even if someone's just waking up right now, they could put in the direct chat, wait, I missed that. Wait, where'd the 160 come from? It's okay. And if it happens 4 times, maybe I'll say, okay, now you have to watch the video. But it's not, it's hard in a Zoom class, okay? I mean, it's hard in life. So do please, in fact, I'm going to switch to you for a second. Well, or no, I'm going to ask in a couple of minutes whether you really get me or not, but you're allowed to not get what I'm saying so far. By the way, am I trying to plead with all of you to see that this crap really makes sense? Really, really, when you think about it? Oh, yes, I am. Am I trying to plead with all of you to see that once you see this stuff, it's shocking how much it makes sense? And it so makes sense. It's so right that yes, in the future, you can do it on your own. And yes, once you look at it in hindsight, it seems like we should have seen this on our own, but it's not the case that we should have seen this on our own. I wouldn't be doing this for a living if I thought that. In other words, what I'm saying is, yes, in retrospect, this stuff makes a ton of sense. Ton of sense means it's not arbitrary. We're not just making it up and wanting you to memorize it. We're not going to give you anything to memorize. We want you to see that this stuff actually makes sense. But that doesn't mean that if you didn't see it immediately that you're dumb. Not at all. No one sees this stuff immediately, right? So what I'm saying is, therefore, it takes time. Therefore, hang with me. Even if I make sense out of it, even if I'm yelling and making it sound like it should make sense, that doesn't mean you were supposed to see the sense 2 minutes ago or even right now. So please keep asking questions. I'm not done yet, by the way. You might have lost. Okay, like I'm not even done yet. What I'm saying so far is, where the only equation we have, or the only definition we have right now, is average speed is distance over time, or the modification average velocity equals is defined to be displacement over time. That's all we have, and that's all we're allowed to use. But that actually churns out a lot of information that we might not have realized it can. I'm just turning over and over that one equation and like spitting out all this information. And that is what I want you to see. That's all that's happening. So far, I'm saying so far, this whole round trip evidently is meant to take 2 days, like according to the given in the problem. I'm saying that's a fact that we just figured out. Like, in effect, we were told it in the problem, but it just wasn't explicit, but it's there in the problem that the whole trip must take 2 days. However, I'll put that as like a fact, so fact A, if you like. Fact B, what we just figured out a couple of pages ago, the out trip. Now, this is not a, we independently, well, okay, we just figured out that the whole round trip time must be 2 days. We also figured out on the previous page, we didn't figure it out, we know from logic that the in trip, which is what we're looking for, must be the total minus the out. I mean, that makes sense, right? The in trip will take whatever time is left over, after you've used up some of your time to go out. Whatever time is taken up from 2 hours for you to go out. But now the catch is, and I'm sure many of you are seeing this as I'm saying this right now, I hope, or maybe you saw it 2 days ago. The thing is that see previous page. T out. We just figured out on a previous page, and we didn't have to figure it out, was 2 days. According to facts, so the problem said it's 80 kilometers to grandma's house. Oh, and by the way, we're also in the direct chat again. Wait, did the person tell me? Oh yeah, she did. He did. He or she did. Okay, cool. Thank you. In the problem, it's 80 kilometers to grandma's house. We drive out at 40, or we walk out at 40 kilometers per day. We want to come back, and we want our average speed for the whole round trip to be 80 kilometers per day. So the question is, how fast do we need to come back to yield that average? And when we break down the actual facts of distance and time, what it looks like we're saying is, okay, for the whole thing to be a round trip speed of 80 kilometers per day, that means we want the whole thing to take 2 days, because 80 kilometers out, 80 kilometers back, and we want to go on average 80 kilometers. So I mean, if we took 1 day to go out and 1 day to go back, sorry, if we want the whole thing to take 2 days, we want it to be equivalent to taking 1 day of going out and 1 day of coming back. But what we just found out is we only went out at 40 kilometers per day. So we took 2 days to go out. We have exactly 2 days to do the whole round trip. But of those 2 days allotted for the whole round trip, we used up all of them to go out. So at what speed could we go to come back in time to use up whatever remaining time we have to make it back? There is no remaining time to come back. So there is no finite speed we could go that would make it back in time. We've run out of time. In other words, the answer is infinity, or in other words, there is no number large enough to accomplish this goal. The answer to this question is it cannot be done. You cannot be done at finite speeds. Red Riding Hood would have to go at infinite speed. She'd have to get from grandma's house to home in 0 time. It's like a dividing by 0 thing. Some finite distance she'd have to do in some 0 amount of time. So she would have to travel at infinite speed. It can't be done. Physically, it cannot be done. That's the answer. I'm going to pause for a second and just look in the chat. So the answer is it can't be done. But the answer is pardon me for a second. The answer is it cannot be done. That's a little bit obnoxious. That may make, I don't know how you feel about that. Well, wait, first of all, hold on, let me look at the time. The answer is it can't be done. I do want to say and I feel a little bit bad about that. The first question was a little tricky because the answer we think is right turns out not to be right. And then this question's a little trickier because any answer that we think is right is not right unless our answer is it cannot be done. And some of you may have gotten that, and I'll see that on the homework. I'm not going to, okay. I was just going to ask, good. So at least one person, okay. So let me pause for a second. So at least one person in the direct chat is saying, I'm confused why it is impossible. And I really appreciate that honesty. Like, let me, I kind of don't want to go on until at least most people, at least anybody who's trying to get this can get this. I am saying it's impossible. I will re-explain. I mean, thank you, direct chat person. And please, other people, just give feedback in the direct chat at any moment. You can always just say in the direct chat, like, I totally get what you're saying. And you can move faster. You can say that. Or say, I totally don't get what you're saying. Like, again, in a Zoom class, especially because sometimes I have to change the view and I can't see your faces or whatever. And sometimes just please. So I appreciate that someone said in the direct chat that they are confused. I'm going to re-explain, or I'm going to try to explain a different way why it's impossible. But before I even do that, let me say, please note, as tricky as this question may seem, or as obnoxious, and in a way it is obnoxious, or it's an alert to how things can be obnoxious in space and time. I do want to be clear, I'm not trying to make anybody feel dumb, really. And I got it wrong the first time I did it, definitely. But also, I'm not trying to be unfair. Like, I'm not giving you a homework question that said that where you literally can't solve the question. I'm not saying there's no solution to this question, or that there's nothing, that anything you would do on this problem can't get full credit. Like, if this were on the exam, there is an answer that would get full credit, and there's 5 steps of work that would get full credit. And the answer is infinity, or the answer is no finite speed will work, or the answer is physically this action can't be performed. I just want to be clear before I answer the direct chat person of like why it's impossible. I'm not saying solving the question is impossible. I'm saying that the solution to the question is the act is impossible, right? I mean, that's the answer. It is an answer. It's just a sort of maybe unexpected or surprising answer. Now, and also it gets us into infinity, which we have to get into next. The calculus was required for this class. Put another way, infinity is not an illegal concept in physics. Infinity is not off the table. Infinity is a very mathematically viable concept. Just sometimes it refers to things that we can't do physically. So that's where there's a physics class to address that. But okay, so I hope, and again, there's tons of ways to get full credit on this, but my goal now, whether you got it right at home or not, I want to see if now we can be clear on why it's impossible. So again, somebody in the direct chat, thank you. It said they're confused why it's impossible. What I'm saying is this. What we're looking for, what the question's asking us to solve for, is the average speed that you would go on the way back, or like the speed that you would go on the way back, such that your average for the whole thing, is 80 kilometers per day. Okay, so a fact is that the average for the whole round trip has to be 80 kilometers per day. And the question is, how fast do you come back such that the average for out and in is 80? Okay, so now another fact that was given is on the way out, you went 40. Okay, so you went out at 40 and you want your average for the whole thing to be 80. So the question is, what do you do on the way back? Well, the first thing I'm saying is the only way to think about average speeds, the only correct way to think about average speeds is distances per times. If we're looking, if we have information about average speed, then that means we have information about distance per time. And if we're looking for an average speed, we're looking for distance per time. So they told us that on the way out, they told us that the distance is 80 kilometers. The distance is 80 kilometers. And on the way out, it was given that our speed on the way out is 40 kilometers per hour. Hold on, I'm just changing the view so I can see the person I'm talking to, even if it's a black box, I just want to see. Okay. I mean, I'm talking to everybody, hopefully, but it's 80 kilometers out. We went out at 40 kilometers per day. That right there tells me it took us 2 hours to go out. And please, in the direct chat or in a minute or now, tell me like where you lose me. Like, tell me which step, like step 1 I'm saying, or step A I'm saying is, I think it took us 2 hours to go out because it's 80 kilometers out and we went at an average speed of 40 kilometers per day. So so distance equals rate times time, or however you want to say it, speed equals distance over time. So I think it took us 2 days to come out. The thing is, if we want our average for the whole thing out and in, if we want our average speed to be 80 kilometers per day, that means we want to go out 80 kilometers, come back 80 kilometers. That's a total of 160 kilometers. We want to do 160 kilometers at an average rate of 80 kilometers per day, like distance equals rate times time, or rearrange average speed equals distance divided by time. So if we're going to do 106, if our distance is going to be 160, and we're going to do that at an average speed of 80, that means that whole thing should take 2 days. like 160 divided by 80 is 2. Like if we want our, I mean, let me just give another, can I give another example? Yeah, I mean, well, I'll just say the sentence in a different order. If I'm driving along at an average speed of 80 kilometers, or if I'm going at 80 miles an hour, I'm going around at 80 miles an hour, and I have to drive 160 miles, it's going to take me 2 hours, right? I am claiming that if I'm going at 80 miles per hour and I have to drive a distance of 160 miles, then it'll take me 2 hours to drive that. So I'm using the same logic here. I'm saying they want my part of what might be confusing anybody in the room is the fact that it's a round trip, like that gets into the distinction between speed and velocity. Don't think, it doesn't matter really that it's a round trip. Just think of it as a total trip that has 2 legs, like leg A and leg B. You can line up the legs. They could be 2 legs next to each other if that makes it easier for you to picture, like out and then out again, if you like. The point is, we have to go 80 and then 80 again. That's a total of 160 kilometers. We want to do that at an average speed of 80 kilometers per day. So we have precisely 2 days to do this whole round trip. What the problem, if you break the numbers down that the problem is giving you, what the problem in effect is saying, what speed should you drive on the way back so that you can do the whole round trip in 2 days? That's what it's asking. What speed should you drive on the way back so that you can do the whole round trip in 2 days? But if you look at the other numbers the problem's giving you as well, it's also telling you, oh, and by the way, you're going to use up 2 days just to get out. That's what I'm saying, is that we used 2 days to go out, but we need to do the whole round trip out and in 2 days. There's no time left. We used it all up on going out. Let me say one more thing about that. And then I really need to know in the chat whether that helped or not. I honestly need to know, because I'm sure it's one person in the direct chat, but I'm sure that person is not alone and is doing a favor to everybody. Let me put this one last other way too. I'm saying when I say, wait, we took up the 2 days already. We took up the 2 days. Oh, everything I'm saying is about the specific numbers that were given in this problem. Like all the concepts I'm saying are about the concepts. But when I say this can't be done, believe me, what I should do for homework is, or you could do for practice, you could totally make up a situation with numbers where you can do it. I'm not saying that you can never do a round trip or something like if the numbers had been slightly almost anything but these numbers that we picked. Of course, there's a speed where you could come back fat. Like, put it another way, if we had said that this entire thing, if we had given all the same numbers, but said that it was 79 kilometers to grandma's house instead of 80, or if we'd said 78 kilometers instead of 80, or we'd said 60 kilometers instead of 80 and left all the other numbers the same, there would definitely be an answer. It would be a high number. I mean, we have to go pretty fast. The shorter the whole journey, the less fast we'd have to go on the way back to make this work. But if the journey were anything shorter than 80 kilometers, there definitely would be a number that you could go back that would, use up your remaining time appropriately so that the whole thing adds to 2 hours or whatever. But in this case, given these numbers, we needed to use 2 hours to make the whole round trip, and we already used up exactly 2 hours just to go out. So there's no time left to come back. So there's no speed we can go on the way back. That's what I'm trying to say. I'm going to look. Okay, I'm going to look in the direct chat. Oh, and there's a lot in the direct chat now. That's great. That's great. Seriously, the more there's in the chat, the more I feel like this is a class, really. And obviously, as we get more and more comfortable, I hope you feel more comfortable putting in the public chat, but that's fine. Okay, so I'm just looking. Also, someone just left, so that's not a good sign, but okay. I'm going to assume it's 80 kilometers to their bathroom. Okay, I'm confused why it's impossible. Let me just see. Okay, and I'm skipping somebody. I'm just going to see the follow-up to the person. Thank you for following up, person. So if I'm okay, forgive me, this is the person in the direct chat originally. I'm not saying names, but I think this is great. They're saying, so if I'm understanding it correctly, if I'm understanding it correctly, because the whole distance is 160 kilometers and we were trying to get 80 kilometers per day, then it would take, okay, they're close. Okay. They're saying the whole distance is 160 kilometers. That is true. The whole round trip is 160. And we're trying to get 80 kilometers per day. We're trying to meet that goal according to the problem. That is true. And therefore, I'm saying if that's true, so I'm adding something to the direct chat now. If the whole thing is 160 and we're trying to get 80 kilometers per day, I'm saying that means if you do the math, if you just write out the equation, that means we're trying therefore to do the whole round trip in 2 days. In 2 days, I'm saying the problem doesn't like explicitly say that, but the facts of the problem mean in order for us to accomplish our goal, if our goal is to have a round trip speed of 80 kilometers per day, and the whole round trip distance is 160 kilometers, then what the problem is really saying to us is our goal is to do the whole round trip in 2 days. Okay, but, and here's now me, not the direct chat, then the direct chat person says something else. But what I'm saying is the but is a separate calculation, just taking the fact of just looking at the out trip. If you look at the out trip, it's 80 kilometers, that's a fact. And it was told to us in the problem that we went out at an average speed of 40 kilometers per day. Notice I haven't used that fact anywhere else, but that fact is a fact. I mean, it's got to be important for something. So if we went out at an average speed of 40 kilometers per day and did that for a distance of 80, that means given fact of problem, that means it took us 2 days to go out. But I'm saying we just established a minute ago that we have exactly and only 2 days to do the whole round thing. So so there's something in the direct chat, this person saying something about 1 day. I'm not actually even saying anything about 1 day. I'm saying we have a goal to do this whole thing, this whole round trip in 2 days. That's definitely precisely our goal according to the problem. But we have this fact that we already took exactly 2 days just to go out. So there's no time left to come back is what I'm saying. Like I think the direct chat person is getting there. And I encourage that and there's other direct chat people too. I'm going to get to you now, but please, again, even if we take was I going to teach other things today? Maybe. Do I care? No. Like if I can literally see in the chat that there's anybody in this room who didn't get it before and is progressing closer to getting it now, and then electron willing, they get it by the end, that's called education. Like that's called you getting your money's worth and me doing my job. Like that's called the point of all this. So I'm really glad that people are admitting in the direct chat, even when they like think they're getting it, but they're still not quite getting it. That is like what class is supposed to be about. Okay, so like if I have like 6 minutes, I want to straighten this out for whomever, anybody who has the guts to be in the chat. And by the way, also those of you who think you get it, cool. I mean, who got the right answer 10 minutes ago or 10 days ago or whatever, cool. But believe me, all that really, like, I'm psyched. And I want to find out eventually who got it or whatever. But if you got it already and you are thinking to yourself, like, why are these other people asking these questions? Like, I get it. Like, can you move on? Like, no, honestly, if you get it already, the advantage that gives you is you can relax. You know you've got it now, so you can relax, but instead of tuning out, you can listen to the thought process, the different ways I'm trying to say something that you already get. Because the real thing I'm trying to teach all of you is to how to get things that you don't get, right? And one way is to say the question many, many different ways and look at it many, many different angles. So those of you who do get what I'm saying already, try to listen for the process that you'll get more insights because your brain is relaxed and you're not hung up on the right or wrong anymore, okay? But don't think that the end of the road is an answer. Please also notice how intense I sound right now. I'm not angry at anybody. I'm intense because I'm excited, because I'm joyed, because we're in the middle of a learning process here. And please remember that I have thought about this stupid question like 3 times a day for 30 years, really. right? I've done this question 3 times a day for 30 years. So that means 2 things. One, if I make it sound like it's clear, that's because I've thought about it so many times, not because it was that clear to me the first time. Number 2, note how excited I still am to talk about it 30 years in. What that should tell you is just because you get it once should not be the end of the road. It doesn't have to be boring or like a conquest just to see an answer once and then move on. Like looking at similar things from multiple angles is called like education and intelligence and getting smarter. And it's called the tool that you need when you finally look at something you don't get to wait. I'm gonna go. So there's 3 minutes. Let me look back in the chat. So wait. So he's confused about the problem. Okay. I watched one of you. Oh, thank you. So someone put in something nice that the YouTube thing clarified. That's awesome. Those of you who are using the YouTube or subscribe, good. Like anything, if you, the more deeply we can understand small things, the better. Instead of trying to understand many, many things thinly. No, good. Thank you for the comment about the YouTube. I'm going back now. If I'm understanding, I'm also looking. I know we end in 3 minutes, but just bear with me. If I'm understanding correctly. Oh, wait. So I just read that. Okay. Now, so now I'm in the everyone chat. So the reason it's impossible is because Red Riding Hood has to go 80 kilometers per day, but her speed is already 40 kilometers per day. And so she will, yes, no. So the person, so Samuel, I mean, he put it in yet different words. I totally agree with his words. Yes, if that helps him or anybody, yes, he's got it. That, and I could dwell more, but I'm looking at the clock. So yes, if you look at Samuel's thing, he's certainly right. If that helps you, and then Nicholas is, so you're basically looking for how fast you would need to know. Yeah. So Nicholas, what I'm saying, the question translates to, you're basically looking for how fast she would need to go back in order to complete the entire trip in 2 days. Yes. By the way, yes, I am. That's what I'm saying. And therefore, if you think of it that way, you realize it can't be done. Also note, please again note, since I only have 2 minutes, this is also the importance. Do you see how this seemingly simple question, and it's not a trick question, it's just tricky. It seems simple, but that doesn't mean it's easy. Welcome to physics. But notice that part of the art of dissecting this question is just that, is if we really translate the question, if we really see that what the question's really asking is what it sounds like it's asking, what's the average speed? It sounds like it's asking what's the speed on the way back, such that the average speed for the round trip is blah, blah, blah. But I'm saying if you write that down enough and tweak it enough, you ultimately see that what the question's really asking is how much time should she take on the way back so that the entire time is 2 hours. Like I've translated the question to time intervals because that makes it concrete and real. And also notice that everything we're saying is just about one equation. This is just one equation, turning from angle and angle and angle. That's both the beauty and the horror of physics, but it's beauty if you take it the right attitude. Okay, so can we estimate that she could move faster than 40? We could estimate, so this is the last thing in the chat, and I know this is our last minute. We could estimate that she could move faster than 40, right, yeah, and the answer is definitely going to be something faster than 40 for sure. In fact, it's definitely going to be something faster than 80. But if Sam's asking, I'm not sure, and we might not have time to address it. If Sam is asking, couldn't she go faster than 40 on the way out? Well, no, or slower. Like what's a lock? It's a given in the problem. We're just told that she goes 40 on the way out. So now how fast does she have to come back to make the whole average 80? Oh, yes, I agree. It's definitely going to be a number faster than 40, higher than 40, and it's going to be higher than 80. Only I'm saying, if you really look at the numbers, it's so high that it's infinity. Oh my God. Sorry. Okay, so wait. I think the only thing that's a little disturbing to me, not disturbing, the only thing that's like worrisome to me is I got these great comments in the chat that I think are great, but I don't know if I resolve them or not for those people. So I please encourage people, especially if you put something in the chat, either text me later, or you can hang out for a minute, maybe if you want, but we have to go. So text me later or put it in one of the game terms assignment, or remind me first thing in the next class period on Wednesday, I want to, this dialogue is what it's about. And the more time we spend on these kind of things, the faster we can go on things later. I promise you that. But we should get this straight. Okay, your questions are great, but it is 1:30. You have to go. I have to go. So thank you very much. Just keep doing what you're doing. Hang out for a second if you want to ask a question or whatever. Thank you. Yes, have a great day.
Thank you, Professor.
Thank you so much. Thank you. Thank you. Oh, cool. Oh, you guys, I don't know if you're there on purpose or not, but are you okay? Great great question. Did you want to say any follow up?
I just want to say I'm still kind of confused because like